Okay, so in this video, I'm going to go through the 3.1 free energy diagrams worksheet. So the first 2 pages is just reading about free energy diagrams, gives you some more information about free energy diagrams, how they relate to activation energy, delta G, and everything like that. So looking at 1, it says label each reaction diagram as either endergonic or exergonic, and then 2 says explain how you know. So our first A is going to be exergonic, and B is going to be endergonic. And we know that this is going to be exergonic because, let me find my pen. We can see that energy, or our products are starting with a higher energy than our reactants. So that means that energy is being released during the reaction, and exergonic reactions will always release energy. We know that B is endergonic because our reactants start with lower energy than our products. So that means within our reaction, they are absorbing or taking in energy, and that is the defining characteristic of endergonic reactions. Then looking down here, labeling our free energy diagram, we have energy of reactants, energy of products. Our activation energy is going to be this hump here. And then our delta G is going to be our change in energy from our reactants to our products. And then on the last page, it says which forward reactions, so going this way, is going to occur faster, A or B. And I said A is going to occur faster. And in this case, they're both going to be spontaneous. They're both going to be exergonic because we start with products that have higher energy, we start with reactants that have higher energy than our products, but we have to look at our activation energy. So these humps here. B has a much larger hump to get over in order for this energy to proceed, where A has a smaller hump. So the smaller hump, the smaller amount of activation energy needed, it is going to be easier to have the reaction go forward and proceed. Here, diagram has a 2-step reaction. A plus B goes to C, and then C goes to D plus E. So write A plus B, C, and D plus E on there. So we have A plus B at our beginning. They are going to be our first product, or our first reactants. Then C is going to be in the middle. So that's going to be both our product and our reactant. And then D plus E is going to be our final product. So then it says which reaction step will happen faster. So C going to D plus E will happen faster. This is going to be because it has a lower activation energy. So if we look up here, A plus B has a much higher activation energy than C plus D. And then also it is going to be spontaneous. So because this is an exergonic reaction, right, we have a product that has more energy than our reactant. So exergonic reactions are going to be spontaneous. So that means it is going to happen faster as well. So then the next one asks for a dash line if we have an enzyme to speed up the slowest reaction step. So the only thing that would change is our activation energy here from A plus B going to C. Everything else would follow the same line. So I tried to draw pretty close to on the same line. The only thing that would change is our activation energy, because that is all that enzymes change. Enzymes do not change our delta G, so our ending delta G or our delta G from A plus B to C, that's not going to change. Just our activation energy is going to change. And that's what I wrote there. So if you have any questions on this worksheet, let me know and I would be happy to answer them.